All right, welcome to day 1 of our Unit 10 review. You should have out your packet from last unit open to your homework, which was page 13. While we're going over the homework here, the sub will be passing out a new packet for you, a blue one, and also a sheet of graph paper. Most of the graph paper is two-sided, so if you have a two-sided sheet of graph paper, you'll need one sheet. For 7th period, when we get to the end of the two-sided ones, there might be some single-sided sheets of graph paper. Those you'll need 2 sheets. Okay, but everyone only needs 1 sheet of graph paper if you've got the two-sided graph paper. All right, so the first one, we wanted the 7th term of the sequence. Notice we're not subtracting the same thing every time, because that'd be subtracting 10 every time. So it is geometric. Do the second divided by the first to get that your r is 1/3. Fill it into your geometric sequence formula on your reference sheet, and we get 5 over 243. Next one, we are multiplying each time by 5, meaning it's geometric. We have a series. Okay, notice series, not sequence, so therefore we have to use the geometric series formula on our reference sheet. Fill everything in, and either of those answers are okay that are boxed because our decimal terminates. Number 3, the easiest way to tell if something's a factor is take what will make it equal 0, so -3 in this case, put it in for x, whatever we get back is the remainder. So we get a remainder of -63 here. Is it a factor? No, because we did not get a remainder of 0. You could have done the division using synthetic division to get what the remainder was too. That just takes a little bit more work. Couple things we needed to find. We needed to find each of our roots, so we end up getting x equals 3, x equals -4, and x equals 1. Keep in mind at x equals -4, we have to bounce. To find your y-intercept, put 0 in for all the x's. We get those things in parentheses there. If we multiply that out, we get +48. That's our y-intercept. And if you multiplied everything out, your first term would be a positive x to the 4th. When you put both negative and positive numbers in there, we get back positives. So that's why our end behavior, we're going up on each side. So from our roots, we got to go up on each side because of the end behavior. We'll bounce at the -4, and then we'll pass through each of the others. All right, so if we could flip to page 1, this first slide is not in your packet. So if you could please just write it down in the space in between the top and bottom printed stuff on page 1. So we'll give you a moment to write out each of those 6 trig functions. So what we're looking for here is just in terms of opposite, adjacent, and hypotenuse, what each is represented as. Well, using SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now the other 3 are just the reciprocals of those, meaning we flip those fractions. Now your calculator can be a good resource if you forget those. If you hit the trig button, they go in corresponding order. So first comes sine, then cosine, then tangent, and then the second group of 3 goes in the corresponding order of which they match with. So it goes cosecant, secant, cotangent to match with the original 3. So cosecant is h over o, secant is h over a, and cotangent is a over o. Okay, so again, you should have that right wherever you have space on page 1. Some things from the trig unit that are helpful to know. We have our different identities. Your quotient identities, tan can always be found by doing sine divided by cosine. Since cotangent is the reciprocal of tan, cotangent is just the flip of that, cos over sine. Now, some other ways your reciprocal properties could be written. Cosecant is the reciprocal of sine, so original sine is sine over 1, so when you flip it, you get 1 over sine, and similar idea for secant and cotangent. Down on the bottom, we have our main Pythagorean property for trig identities. Sine squared theta plus cos squared theta equals 1. There are two additional ones that you can get from that original, cos squared, that you can get from the original and using the things from above. So if we take this original one and we were to divide everything by sine squared theta, anything divided by itself just gives us 1. From up above, we know a cos divided by a sine is a cotangent, so this would give us cotangent squared theta. And then a 1 divided by a sine we know from above is cosecant, so this is cosecant squared theta. Taking that same original one again, we could get a different Pythagorean identity by instead dividing all of them by cos squared theta. A sine divided by a cos we know from above is a tangent. So we get tan squared theta. Anything divided by itself is 1. And then 1 over a cos gives you a secant. So we have secant squared theta. All right, so those are just some identities for trig functions. If we go to the next page, if you're on the unit circle, your sine is the same as the y value, the cos is the x, and the tan is the y divided by an x. Usually you don't need to see that. Usually you don't see that much on the Regents exam. But something you saw last year that will come into play sometimes on the Regents exam is our ASTC. So these letters stand for which trig functions are positive in each of those quadrants. And if you look at the bottom of page 2, we have it written out there. So the A stands for all, so meaning all trig functions are positive in the first quadrant. The S stands for sine, meaning that sine is positive in the first quadrant, meaning the other two, tan and cos, are negative. Now, wherever sine is positive, cosecant would be the same, and likewise for the other reciprocal properties. In the third quadrant, the T stands for that tan is positive, and the other two, sine and cos, are negative. And in the fourth quadrant, the C stands for cosine is positive in that quadrant, while the other two, sine and tan, would be negative. All right, moving on to page 3. We want to use one of our Pythagorean identities, which is given to us there, sine squared theta plus cos squared theta equals 1. We want to eventually find what tan theta is equal to. Well, we need to keep in mind something we saw on one of the other pages, that tan theta is really just sine theta over cos theta. Well, notice they tell us that cos theta is negative 0.7. So we know the denominator here is just going to be negative 0.7. All that we need to do is find the sine value. And we can find that by using our Pythagorean identity. When we have a sine squared theta, what that really means is that the entire sine theta is being squared. Likewise, this means that cos theta is being squared. So we can replace our cos theta with the minus 0.7 that they told us in the problem. So what we're going to do is we're going to pause the video for 1 minute, and what I'd like you to do is square out that negative 0.7, making sure it's in parentheses. Okay, if something is written in a certain way on the board in the problem, you should make sure you're putting it in the calculator exactly as it looks. And then see if you can move that answer over to the other side with the 1. So we're going to pause the video for 1 minute to allow you to do that. When we initially square it, we should get 0.49. When we subtract the 0.49 over, we should get 0.51. Well, now what we're going to do is we're going to take a square root to get rid of the squared. When you take that square root, we need to remember to put a plus minus out front. So we're going to have plus minus, and we'll give you a moment to put that square root of the 0.51 in your calculator. Notice we will not be at our final answer yet, so make sure you keep it all the way out. So we should get something like 0.7141 and then a bunch of other stuff. Now this is where the fact that they told us we were in quadrant 2 comes into play. From our ASTC, quadrant 2 means we're in the S quadrant. So therefore sign should be positive there, meaning of these two we want to work with the positive value. So let's go over to the far right here where tan was sine over cosine, and in the sine spot we can put positive 0.7141 ... Now when we go to calculate the tangent here, we need to make sure we go up and select that entire decimal all the way out in your calculator when you go to calculate the tan value. So we're going to pause for 1 minute, see if you can punch this in the calculator, and notice we want to round to the nearest hundredth. So we'll pause for 1 minute to allow you to put that in and to properly round it. All right, so when we punch that in, rounding to the nearest hundredth, we should get negative 1.02 for our final answer. All right, moving to the bottom of page 3, the rest of the period we're going to work on graphing trig functions, sines and cosines specifically. So first, a few vocabulary words to review. When you have a trig function graph, the amplitude is the distance from the midline to the max or the min. So for example, say this was some graph that we had. Our midline would be about here. Okay, the midline is sometimes also called a wrap line. Okay, depending on who you had last year, they might have called it either one of those two. So the amplitude is from that midline to the max, so that distance, or from the midline wrap line to the min. Those will be the same distance. Okay, and it's always the absolute value of that, so it's a positive distance we're always saying. So we're just saying how much are we going up or how much are we going down. So that's your amplitude. The period is how long it takes for one cycle. So on our x-axis, whatever that span is right there, the length of one cycle, that's what our period would be. And the frequency is how many cycles would fit into 2 pi. So say that's 2 pi right there. This would be an example of a frequency of 3, because there's the end of the first cycle, there's the end of the second cycle, and then there's the end of the third cycle. So that would be a frequency of 3. So there's a formula that allows you to relate the period and the frequency, and that's one that you'll want to remember. So P is equal to 2 pi over F, where P represents the period, F represents the frequency, and then you have 2 pi. From a graph, you can pick out the period. From an equation, you can pick out the frequency. So 2 examples of equations. Say you have y equals sine 3x. The frequency is always what is in front of the x. Now, if you had some type of shift left or right, that frequency would be in front of the parenthesis. So this is showing a shift to the right 1 because of the minus 1 on the inside. So our frequency is just right here. So it's whatever would be in front of the x. Sometimes we would have to think of it as what would we get when we distribute it through. All right, so as we move on to page 4, we want to have our packets out, but also our graph paper. So the grid that I have here did not show up very well on your packet, so it might be easier to put this on the graph paper. Now on your graph paper, you should either have a double-sided sheet of graph paper, which should be plenty of space for what we do in class today, and then there's 2 graphing ones on the homework. You're welcome to put it on the graph paper if you want, because I don't think the grid showed up well on there either. Now, if you're one of the people probably in the 7th period that has a single-sided graph paper, then you would need 2 of those single-sided sheets. So we don't want to take up the full entire piece of paper. I'd say you might maybe want to take up about a third of a side of a paper when we're drawing these graphs. When you go to sketch in your XY axis, you want to plan ahead based on this phase shift. So right here, inside, we have x minus pi over 2. When you've got a minus on the inside, that tells us that we're shifting to the right. So because we're shifting to the right, we don't have to leave any room to the left of our y-axis. If we are shifting to the left, we would want to make sure to leave some space. Okay, so that's the first thing we want to do, is just plan how we're setting up our xy axis. Next thing we'll want to do is we'll want to come up with our scale on the x-axis. So let's put some evenly spaced out marks, 4 of them total, on the x-axis. I'm going to do mine every 2 blocks. You can do the same. And we want to decide what's going to go with that 4th block. And we'll decide that by finding the period for our function. Remember from the previous page, we have that period is equal to 2 pi over the frequency. And the frequency can be picked out by seeing what would be in front of the x in the equation. So in this case, could we add a shift to the right? It's out in front of the parentheses. So our frequency is the 1/2. So therefore, to calculate period, we will have 2 pi over 1/2. Well, whenever you have a fraction within a fraction, you want to write it horizontally. So we're going to do 2 pi divided by 1/2, because that then allows you to do like you did back in middle school. You can do a keep, change, flip. So we're now going to have 2 pi times 2 over 1, which is really just 2. So 2 pi times 2 gives us 4 pi. So our period is going to be 4 pi. That's what we will label the 4th mark. Now, what we want to do next is label the 2nd mark, because that's halfway to the 4 pi. Halfway to the 4 pi would be 2 pi. Next, we'll label the 1st mark, because that's halfway to the 2nd mark, so that'll just be pi. And then if we count by pi's, pi, 2 pi, so the 3rd one is 3 pi. Next, we want to draw in our wrap line or our midline, depending on what you like to call it. We can determine that by what's being added or subtracted on the end of the equation. Now, before we draw that in, we should put some type of scale on our y-axis, so we'll maybe just go by ones. And usually we draw that wrap line or midline in with a dotted line. So we're putting ours in at -2 because we have the -2 on the end of our equation. So we did our x-axis scale by finding the period, then we drew in the wrap line. Now the key thing to remember when we go to sketch our graph now is that a sine starts on the wrap line, sine on the line, and cosine starts off the wrap line. So because we have a sine, we are going to put our first point on the wrap line on the y-axis. Okay, first point always happens on the y-axis. Now because there's a +3, that means our next nice point is going to be 3 above the wrap line. So by nice point, I mean at the tick marks that we put on the x-axis. So at pi, we should be 3 above the wrap line. Not 3 above the x-axis, but 3 above the wrap line. Now that gives us the maximum of the graph. Once you're at the maximum, we've got to head back to the wrap line. So at our next nice mark, 2 pi will be back on the wrap line. So we went wrap line to maximum, back to the wrap line, so the next spot to go would be the minimum. The minimum, we have to go 3 below the wrap line. And then to finish off, we come back to the wrap line. Now do not sketch in your graph at this point, because we have not accounted for our shift pi over 2 to the right. So for us, on our scale, pi over 2, or in other words, half a pi, would be 1 box. So we need to move every point 1 box to the right. I think it is helpful to use a different marking when doing that, especially for yours where you probably don't have different colors. So we'll go 1 box to the right for each of those, and make a little baby X. And then those are what we will connect with a nice smooth curve to have our final graph. And we have now graphed 1 cycle of our trig function. So we're going to go over to the packet now, and we're going to answer those things over on the right for this one. The max is just the largest y value that we ever have, which would be 1 in our case. The min is the lowest y value that we would ever have, which in our case would be -5. The period we had calculated to be 4 pi. The vertical shift is how much we went up or down, and that's based on the wrap line, so we went down 2. The phase shift is how much you shifted left or right, and we went right pi over 2. The wrap line needs to be an equation. It's always just y equals whatever that value on the end is. So y equals -2, the wrap line, midline, whatever you like to call it. The domain for sines and coses is all real numbers. That's the symbol for all real numbers. Or if you would actually like to write out all real numbers, you can do that as well. And then the range we get from looking at the min and the max. So our smallest y value is -5. Then we'll leave a little space and we'll put a y. Then we'll leave a little space and we'll put a 1. And then we should put inequality signs both opening towards the big one. So 1 is bigger than -5, so they should both open towards the 1. Now we have the equal to's because we actually hit the values of -5 and 1 on our graph. All right, so we're going to move to the next one. So we would want to draw an XY axis in like the middle third of your graph paper. But before we draw that, we want to plan ahead based on our phase shift. This time we have an x plus pi over 2, meaning we're going to shift left pi over 2. So that means we want to leave ourselves some space to the left of our y-axis so that we will have room to shift it to the left. Okay, so leave yourself some boxes on the left. So that's the first thing we want to consider. Next, we'll do our 4 evenly spaced out marks on the x-axis, and we've got to calculate what our scale will be. To do that, we do our period equals 2 pi over the frequency. Frequency, remember, is what's in front of the x value, and in our case, again, because we have a phase shift, it'll be in front of the parenthesis. So we have 2, so we're going to have p equals 2 pi over 2. 2 pi divided by 2 just gives us pi. So that will be the 4th mark that we will label on our graph. So now we'll go halfway there. Half of pi would give us pi over 2, or in other words, 1/2 pi. The first mark would be half of that. When you take half of something, you multiply the numerator by 1 and the denominator by 2. So we get pi over 4. And then let's count by these. Think of this as 1 pi over 4. 1 pi over 4, 2 pi over 4. So this one is 3 pi over 4. And the third one will always be 3 of whatever the first thing was. Next, we want to put in our wrap line with a dotted line. And in order to be able to do that, let's stick a scale on our y-axis. We're going to have a wrap line at +1, so we'll put that in with a dotted line. And now we're ready to think about that it's sine on the line, cos off the line. And when we say line, we're talking the wrap line. So cos should start off the wrap line. We decide where to start by the number in front of the cos. We have a +2, so we should start 2 above the wrap line. Because this is above the wrap line, that means we're at the maximum. If you're at the maximum, the next place you must go is back to the wrap line. So our next nice point will be at the pi over 4 on the wrap line. We went maximum wrap line, so next thing we have to go is the minimum. So this time we should be 2 below the wrap line, then back to the wrap line, and then back to the maximum. Do not sketch in your curve yet, because we still have to account for our phase shift. So we have plus pi over 2, so that's going pi over 2 to the left. Based on our scale, pi over 2 is 4 boxes. So each point we've got to move 4 boxes to the left. I like to, again, put a little different marking so it's easier to see, especially when you don't have different colors. And then we'll sketch that in with a nice smooth curve. So we're going to go back over to the packet and we'll answer the things over on the right. Maximum is the highest y value that we see, so we'll have +3. The minimum is the lowest y value that we see, so -1. The period we calculated just to the left there is pi. That's the length of one cycle. The vertical shift, we went up 1. The phase shift, because of the plus pi over 2, we went left pi over 2. The wrap line is always y equals, and then whatever number for the wrap line, so y equals 1. Domain for sines and coses are always all real numbers, because even though we only drew one cycle, these would just keep going through forever in each direction, right and left. And range, we'll use the max and the min. So we've got -1, leave a little space, and then y, leave a little space, and then the max 2. They should both open towards the largest one, so the 2 in this case. Now another way to get your max and the min right from the equation is you just take your wrap line and add the amplitude. To get the max, take your wrap line and subtract the amplitude to get the min. All right, so we'll do one more example. So going over to your graph paper again, you should have 1/3 of your front side left. The back side, again, you can use for the homework ones that you're graphing. We want to first look at that phase shift to plan ahead. We've got a minus pi over 4, so we're going to shift right. So therefore, we don't have to leave any space to the left of the y-axis. We'll put our scale with 4 evenly spaced out marks. We'll go to our period formula, P equals 2 pi over F. F is what is in front of the X, and again, it's in front of the parenthesis because we had a phase shift. So we'll have 2 pi over 4. 2/4 reduces to 1/2, so that gives us pi over 2. So our fourth mark will be pi over 2. The second mark should be half of that. When you take half of something, multiply the numerator by 1 and the denominator by 2. So we'll get pi over 4. The first mark should be half of that pi over 4. So multiply the numerator by 1, denominator by 2, and we'll get pi over 8. And then think of that as 1 pi over 8. So we'll count 1 pi over 8, 2 pi over 8. So the third one should be 3 pi over 8. Next up, we got the wrap line, but let's make sure to put a scale on our y-axis. Our wrap line will be at +3 this time. And now we want to be thinking sine on the line, cos off the line. And when we say line, we mean the wrap line. So sine's first point will be on the y-axis on the wrap line. We have a -1 in front of our sine, which means we'll go down 1 for our next point. Since we're below the wrap line, that means we're currently at the minimum. So we got to come back to the wrap line, go to the maximum, back to the wrap line. But do not sketch it in yet because we still have to do our phase shift. So when we do our phase shift, we want to go right pi over 4. For us, that's 4 boxes. So each point will go 4 boxes to the right. Again, I like using a little different mark. 4 boxes to the right, 4 to the right, 4 to the right, and 4 to the right. Sketch that in with a nice smooth curve, and that would be one cycle of our graph. In reality, it keeps going forever in each direction, but you usually only sketch one cycle of it. Max is the highest y value, which in this case is 4. Min is the lowest y value, so 2. Period we found to be pi over 2. Vertical shift, we moved up 3 for the wrap line. Phase shift, we moved right pi over 4. Wrap line was at y equals 3. Domain for coses and sines is always all real numbers. And our range, the lowest was 2, then y, and then we've got 4 for the max. And we should both open towards the big one, so open towards the 4. All right, so that's it for today. Any other time left in the class you can use to start your homework. Again, there's 2 graphing ones on the homework. You can put those on the back side of your graph paper because I don't think the grid showed up great in the packet.